Hey, good morning and afternoon, everyone. It's 11 o'clock. We know people are going to be joining slowly. My name is Bob Clark with the INS3. I'm going to kind of talk a little bit about logistics. I will repeat it again towards the end of this, just so everyone hears it. But you all came in, you're obviously muted. You're going to be staying muted um, during the presentation and demonstration. If you do have a question, please enter it into the Q&A. There's also a chat window which you can chat with Isabella, who is moderating the presentation and everything. And at the end of the meeting, we'll be done probably about 10 minutes. So Shirley will start going through and answering any of the questions. And any of the questions we do not get a chance to answer, we will follow up with you via email. Okay, quick agenda. I just talked about logistics. We're going to give a quick introduction to INS3, and then we'll do some Sorba. And we're actually going to be showing the product and showing a couple demonstrations of what you're doing so you get a good view of the product. There are a lot of capabilities in the product. One of the things for sure is we can dive into any other use cases you may have at a later time or certain of the questions and answering. And that's how we'll end the meeting. Real quick about INS, we've been solving efficiency, quality, cost control, scheduling, basically manufacturing issues, having our manufacturing clients become more optimized, taking care of what they're doing by utilizing data. The core of everything we've done for the 35 years that we've been in business is solving those problems, leveraging technologies from Microsoft, GE, Rockwell, Ignition, framework, Tatsoft FrameworX, Sorba.ai, and many other vendors, right? We work with the software platforms you have to get more value out of that information, converting that data that's kind of gold in your plant, that's kind of hidden in your plant, become more valuable and make your operations better. As a company, we really have four main practices we get into. One is just simple infrastructure, right? Your cybersecurity, your servers, your edge devices that you need, and also then putting in SCADA and historian systems to actually be the storage of all that data. Because really, data is king for improving everything that you want to do inside of your plant. So we'll work with PLCs, we'll do automations, we do alerts, etc. And then we also get into the MES manufacturing space where you can actually start to calculate and some key metrics, right? You can do OEE, you can do genealogy and track and trace, quality, automating manual process, costing, scheduling, and even interfacing with other systems that we don't necessarily work with directly, such as your ERP system, your warehouse system, your maintenance systems, your lab systems, etc. And what we're really talking about today is the analytics piece. Once you have all that data, how do you take advantage of it to do predictive quality, predictive maintenance, condition-based maintenance, digital twins, all of that information. And that's where we're going to focus most everything in this presentation. One of the things that we're a big believer in is the idea of a unified namespace, because really what it does is you have call it big data. You have a large amount of data hidden in your plant. One of the key things is to structure it in a way that it can be shared and templatized throughout your operations, making things faster to develop, which also makes it lower cost to develop, and also unifies things as it goes across your enterprise from plant to plant to plant. I'd mentioned some of the things we typically do, but a lot of OEE, scoreboards, dashboards, alerting, interfacing. That's mostly of what we do, and we deliver that to the right person at the right time on the device they use, whether that's mobile, tablets, big screen TVs in your office, or just websites from their house in a very secured fashion. And in the space of AI and what people are doing around machine learning and some of the tools we're showing you today, just giving you a small idea of some of the use cases you could have and some of our customers that have gotten value out of using these, such as one customer reduced almost 50% their maintenance time by getting insights into any issue that they have in pumps across a a large sewer district. Another customer was looking at their quality of the roasting, so they made first pass quality the right way, the right time as changing conditions. Humidity suddenly goes up. What are the quick adjustments, closed loop adjustments that can be made in real time? So we always make the highest quality product that is used in some of our other products. There's also another opportunity where a customer saved a lot in rework, six figures plus, where they were able to predict a quality issue that wouldn't show up until 1 to 3 days later, having to do with the viscosity as the product set. A new thing that's been coming up a lot is also as you move maintenance materials around via AGVs, people are looking to optimize the paths that those AGVs have. Another customer got a 1% more throughput by realizing, and the analytics showed it, that their materials have a personality, but their machines also have a personality. And if we can optimize which materials, in their case, cheese, we send to which line, we see another improvement. So they were able to quickly do that and be able to optimize and really just get a return out of putting the ideal material in the ideal place. Another thing that's been a big trend lately is schedule optimization. How do we balance our changeover times and our run times versus our inventory costs, and how do we optimize that overall? And there's many more. And Brian will talk about some specific use cases, but we'll talk a little bit final about our process that we work through with our customers. And this is really all about discovery. What are the issues that you're having in your plants? What is the data you have in your plant, and how can we put those two together to really deliver some business value? And this is INS's proven process across the board, right? It's initial meetings with you. We do a lot of times we'll do a plant walkthrough or a working session. So we really have a good understanding of your as-is state, where we can bring that 35 years of manufacturing experience to the table and be able to give you a readiness survey where we can actually give you a path forward, whether that's a pilot, a project, some additional consulting, or having to update some of the systems you have in place. So that I am going to repeat for the people that came a little bit later, the logistics of the meeting, but when you came in, you were muted. We're going to keep you muted throughout the presentation. If you do have questions or need to interact with someone, use the Q&A section. Isabella is monitoring the chat and QA. She will collect all those questions, and we'll be answering them at the end of the webinar in the last 10 minutes or so. And if you have anything else with that, I am going to introduce Brian Thinken from Sorba.ai, and he is going to take over from here.
Appreciate the introduction. Yep. Thank you very much, Bob. Appreciate the introduction. Love being on with systems integrators who are going out and leveraging their expertise to help solve problems in their verticals that they are experts in. Who is Sorba and who's using it? So Sorba's been around for roughly 10 years now. We actually started out of the systems integration space. The two co-founders of the company, Aldo Frante and Yanni Perez, both come from a systems integration background. And I think that's critical in kind of the origin story of Sorba. We started out of the plant looking at where the restrictions that come from doing manufacturing work, looking at not putting data on the cloud, running 100% on-prem, solving a lot of those data issues that really plague plants and help create manufacturing value immediately, leveraging the technology you have on-prem. Next slide, please. Bob, there we go. So how Sorba solves this is we have created an end-to-end solution from the data collection, whether that's from an ERP, a CMMS, a historian, SQL databases you might have floating around the plant, to your DCS, PLCs, or IoT devices that you have installed. We have the tools built in to collect all that information, bring it into a single platform where you have all that information stored, and get it prepped for machine learning and AI building. That involves our auto ETL that cleanses that data, gets it prepped, allows you to put additional transformers on that information as it comes across, whether you're moving it from one SQL database to another, or from that historian over into our internal database to build models. That entire solution is there so that you have that ease of moving information around to get it prepped. Once there, you can build models in a no-code manner. So you follow through menu-driven prompts, getting you to the result that you want to have, leveraging your expertise as an SME, not having to have a deep data science or Python background. This tool is built to enable you as an SME to go through and drive to the results that you want to leverage. Once you've built a model, allowing Sorba to help you pick out the correct algorithm that you need to go deploy that model, we then give you the ability to orchestrate that model out to the edge, and also create classes so you can expand that build that you've created, maybe say on a motor, say on a battery pack, whatever that might be. You can then take that build you have, push it out across your enterprise, across your assets, and then allow the models to retrain on their own. If you look at two of the biggest time chew in your AI and model building, it really comes in the data collection and acquisition, as well as the retraining. And we have gone to great lengths to kind of solve those two problems to make it easier for subject matter experts like yourself with an automation background or a process background to solve these problems. Next slide, please. Now, we have a lot of things built into the software as well. If you do have Python models already built, if you have data scientists that are working within your facility, if you have these skill sets available, we've also created the tools to enable their work to be ported in and leverage a lot of the pipelines and plumbing that we have available, as well as the auto retraining, the connection to your tags and database, and managing all those models as you push them out to the edge. So really, it gives the flexibility for a plant to pick and choose what parts and features that they want to leverage to enhance their production, solve problems, look at predictive maintenance issues. Next slide. Additionally, we've created some out-of-the-box solutions so that you don't have to kind of dig through and figure out how you're going to build this model. From vibration analysis, where you can plug in IoT devices, to creating a digital twin where you're looking at your historic data, modeling that, looking forward, creating forecasts or what-if scenarios, as well as predictive maintenance and asset health, where you can look to see if your equipment's going to fail and what are the parameters that are causing that failure, all the way to our advanced process control and multivariate process control, where you can try to optimize motor performance while reducing energy consumption. You can leverage these tools, again, all in a no-code manner to create the result that you're looking for. Next slide here. So when you look at the problems that face nearly every plant, they're around quality control. You're looking at efficiency. You're looking at supply chain and regulatory compliance. All these things really come from these multiple data sources you have to come in. By being able to pick and choose the different parameters, whether that's looking at reported data in your ERP compared to what's going on in your PLC, this is the overall thing that most manufacturers, most producers of goods are trying to solve. And you need all this data coming in so you can build models that are effective and deployable wherever you need that compute to run. Next slide. So this is just a quick example of kind of the results that we have seen with a lot of our customers. I don't look at machine learning as kind of the silver bullet, but what it is, it's another tool that you can add and augment. It's about having your best operators, your best people, embedding their knowledge into the tools that you have and allowing 24 hours a day, 7-day operation to maintain and do closed loop control on those solutions or on those processes. So in this scenario, this is around a filtration system. We were trying to optimize and reduce the amount of DE filtration going through a process. the cost was really the biggest driver of trying to reduce this DE filtration. Not only did we reduce the amount of DE that was being used inside the filtration, but we also increased beer throughput. We also reduced the turbidity, or reduced the turbidity of that product as well. And more importantly, we reduced the energy as well that it took to go across it. So we accomplished our goal by reducing about 500 liters of ERT dosage for every 8,000 hectoliters of beer that went through. But more importantly, we created a consistent output of what the process was doing and what the equipment was doing within the manufacturing environment. And I think that that's where machine learning really goes to the next level above, your standard kind of PID control or other processes you put in place, is you're really able to leverage the data that you have in your systems and your expertise in the facility to create these agents that are going to work 24 hours a day, 7 days a week, to create consistent output on your equipment, give you that insight on when something might fail, and really drive that value and allow you to get to the things you need to be working on, because equipment's still going to break. Belts still need to be replaced. Sensors need to be added on. So it allows operations, process engineers to continually do that work that the humans need to do, and allow software and technology to drive to those things that are rotten repetitive. So I'll dive into this more into the demo, but our software really kind of allows you to work in two different spaces. We also have a lot of features I'm not going to cover. We're going to scratch the surface of the capabilities within the software. We've been around for 10 years. We've built a lot of things in, from video to having an ML agent that we're going to be releasing here soon that will do kind of an LLM where you can type in how many pumps are going to fail. So we're constantly adding into the software. The software currently is divided into two real distinct parts. And one of them is really around kind of what I refer to as the controls engineer side of the house, where you're connecting to data, managing your models, putting things in production, seeing those operational values that you've done. And then you have the ML ops side, which is where your process engineers, your experts on the equipment, your maintenance people are building models from the existing data that you have coming in. So we'll drive through those things here in the demo in just a second. Next slide. All right. So I guess we'll dive right into that. See if I can find the share screen here. All right. So as I mentioned, the Sorba software is divided into two separate spaces. You have the IoT unified side, and you have the machine learning side. I am using in our software instance right now a cloud version of it. Our software is deployed primarily on-prem. And when I see, I'd say over 80% of our customers deploy the software on-prem, no connection to the outside world, underneath their OT firewall. But we do have the flexibility to deploy the software really wherever you want that compute to be. So if you're using your own enterprise network that you've created, you're using an AWS or Azure or Oracle as your cloud provider, we can deploy our compute and our SDE into any environment that you have. I use this out of ease for demos to kind of, but really, regardless of what your requirements are, we can meet that from a technology perspective. So this hierarchy can be mirrored over to your existing SCADA system. So if you have a hierarchy that's built, we can actually connect those two systems together, mirror that hierarchy over, so you don't have to replicate a lot of this work. But as you can see, you drive into this software in a typical manner as you see in a SCADA system. There's a lot of tools that are available within each of these. I'm only going to really highlight a few of them here. As you create an asset, these assets can be really whatever you want them to be. It could be a whole plant. It can go down to a single process. It can go down to a single piece of equipment. In this case, I have a refrigeration application pulled up where it shows all the different artifacts that are then associated with that, from alarms to custom apps that you might want to build depending on operators, to channels connecting into things such as, Rockwell PLCs, creating your own simulators, all sorts of drivers as you connect into the level 0, level 1 in the Purdue model of your system that you have out there. We are constantly adding new drivers into the system. So if you need to connect into different pieces of equipment as you go along, you can build that different driver in there, or you leverage other tools that you have in the systems integration world. We've built a lot of these drivers out of necessity as we've connected our software into moving vehicles, whether it's train or big ore hauling trucks in the mining industry. So we've really done that out of necessity to help manufacturers and producers of goods connect to their systems they might otherwise not be able to. Go back to space. The other thing you can do is build custom dashboards, workflows, create all your tags that are being used in those machine learning models. This is an important piece to highlight. As you're looking to display what the output of what these models are doing, everything in the system is based on a tag. So you may take your input tags from your SCADA system, but then those input tags have output tags depending on what model that you build and are leveraging out. The next piece I want to highlight out of this is really the IoT connectors. And this is a very powerful tool that we have built inside our software. I've been in the space for 20 years. I'm a controls engineer myself. I feel like I've heard the story for forever and ever. Love to get to some of these advanced analytics, but I don't have data in a place where I can access it, or my data is not clean. I need to solve that problem. Well, to get to the thing that we really enjoy doing, which is building models and solving data science problems, we decided we needed to build something to bring all of that different information in from the different sources. So very simple concept, but as we go through this digital transformation in our industry, this is things that all manufacturers and producers of goods, need to go through on their journey. So real simple concept: pick where you want your work to be done, pick a source. There's a whole bunch of different pre-built sources in here to connect to different databases to bring them in, either into Sorba to build these models, or even move data into other repositories that you might want to leverage. So whether it's coming from an API connection, or coming from a Canary historian, or coming from an influx database, all those data sources are available. From that point, it's just a matter of following the menus, filling out the information required to make the connection. Once you then get to the point of that initial source being connected, then you can do some processing. If you don't add any processors in here, that's fine. It'll do some light cleansing and scrubbing and alignment of data, looking for some outliers and cleansing that, getting it ready for machine learning models. But if there's some additional processing you'd like to do on that, we've added in the ability to create that on the fly as it moves from one source to another. So adding in different ways to pre-process your data, downsampling it if you have transmission issues or telemetry issues, writing a custom script in there if you need to, doing statistical process analysis on it, on that data coming across. Really a whole host of different ways to transform that data as it goes from point A to point B. Then once you do that, you put your data into the final source you want to work on it. In our case, we put the data to the Sorba real-time. Sorba real-time is where we access data to build data science models. It's a built-in historian and database we have in our software. But if you want to move it from a Canary database to a SQL database, you can do that as well and build as many of these connections as you need to build the models you want or solve data and plumbing issues within your facility. Inside, some of the other artifacts that we have in here that you can leverage is notifications. In here, we have the model instances. I'll touch on this at the last part because this is where you deploy and manage your models that you've built and putting them out to scale. And then if you need to do any custom scripts as well, this is a place that we've added in that I think is another kind of powerful tool. Now, if you have people write Python or use an IDE on a regular basis, this might not look all that impressive, but one of the things we've done is really connect this into the back end of our software. So it has the accessibility of all the tags that are already available in there. So if you need to do a computation, maybe some very specific formula that needs to be done for a process that comes through, you have the ability to write that in, have it be part of the model and scripting and data collection as it comes in to your system and leverage that. So, and then the final piece we have is the ability to add vision. This vision now ties into your databases, gives you that ability to really leverage time series with the optical values, whether those are radiometric cameras, OGI cameras looking at different gases, or just a standard optical camera that you are using on your computer right now. You can build machine learning models around that. So this is where you do a lot of that controls engineering work, connecting to information, managing your information, and moving it around. When you want to build models, you come over here into the machine learning builder. Over here, you can manage all your projects and manage all the different models you build. One of the biggest value propositions that we have with our software is the ability to iterate quickly. If you look at, and I've heard this from many executives who have demoed software in the machine learning AI space, we started off with a process. We got our data cleansed. That took 6 months. We then went to try to tackle a problem. We built these models. It took a number of months to build the models. We put it into deployment, realized it didn't solve the initial problem we wanted. We were back to the drawing board after a substantial amount of time investment as well as financial investment. Sorba is set out to kind of solve that problem to allow you to iterate quickly and build these models rapidly. So we'll add a new version in here of our data set. So every time you build a model, you want to pick from a data set that's available to you. When we talk about data at Sorba, there's a lot of, I don't want to call them myths, but a lot of, I think, things that have been put into the data science and machine learning world that makes people not want to start as well. I need to have tons of data, 2 years worth of data. That, in our case, is not required. We look at data as we want a good chunk of data that creates value to your process that an SME can leverage and create the value. Put that model in deployment and then let the retraining learn on its own along the way, rather than trying to maybe learn off of 2 years worth of data that the first 18 months really didn't create any value to your current process value. We really like to get started. We've done models on as little as 2 days worth of data, even sometimes as 2 hours worth of data, depending on the granularity. And we can do this because, one, we create generative data inside our software. We've been, as our CTO and co-founder says, we were doing generative AI before it was common knowledge or a common practice in the world today. And the second part is the ability to auto retrain those models. So when you want to build a model, you come from your data set. Now, this is a demo instance. I have a lot of my team and sales engineers and people working in here, but these are all the different data sources we have connected currently. When you click on them, it's going to give me an error. This is what the fun of doing live demos here. It's going to give me an error because I'm going to create a new data set. When you click on these, all your different data sets will start, or tags that are associated with that will start popping up down below. You then can pick the time and date range that you want to look for with that data. Since we're doing a demo, here with, I like to use a static file. I actually do this in a lot of cases when we get started with customers. We will start with a CSV file of an exported process that they have, and we'll pick from that file. I've already gone in here and created this data set so we can look at this data and explore what this data looks like. So this is some motor data that we've brought in to the system. We have a whole bunch of different information. Everybody has VFDs and different things. within their facility. So looking at rotating equipment and VFD performance is always something that we all deal with. So we have energy consumption going here on a totalized value, a bunch of information. Inside here, you can explore the data in a number of different ways, add and subtract the different data you have, seeing how that piece of equipment's performing, drill into it, look at every little piece of it and see what's going on with your equipment to make sure it looks correct. Once you're ready to build a model, then you come over here into the model builder side. And I've built a few models already just so we have them prepared. Just to give a little background on the hardware that we are running on this is all run on a CPU. So we are not running on GPUs. I'm actually accessing a database in our headquarters in Jacksonville, Florida right now. We have another office in Australia. But all of this is being run on a CPU. So we've figured out a way to also get the compute down so you can leverage existing hardware you have in your space. You can spin up on a VM, a Docker, Red Hat, Ubuntu, whatever your kind of preference is from a hardware and deployment perspective. But one of the key things we've done is really tried to simplify the process so that somebody like myself, who has zero data science background other than being in the space as a sales professional, can go and build models. If you have people on your team that have built models, you can come in here, you can build custom algorithms, use this template to pull in those different algorithms and models that you've built so that you can leverage all the pipelines that we have available. But in this case, we're going to go in and we're going to build a model here on the fly just to kind of highlight some of the simplicity of the software. So anytime you want to build a new model, you have your data set selected, you click on new analysis. So in 3 steps, our goal is to get to building a model and having that put in production. So 1, we give everything a name. You can write in a description of what this model is going to be. This is all the data that's available within the data set that we've pulled over. So we're looking at, we have our pump ID, we have, statuses, so binary alarms in there as well. So if we want to look at when the VFD threw an alarm based on the behavior of the motors that led up to that, we can look at building a classification model for things like that. But the ability to pull over all this different data. So I'm going to kick out a lot of the binary tags. We don't need those on here, but I am going to leave the run command in here as one. We'll leave all the different analog values in here. We'll come down here and see what other tags we're going to have. We're just going to build a very simple anomaly detection model in this case. I have a few other, get rid of the e-stop and that right there. So we have all analog values. In this case, we can also add additional features into this with synthetic tags. Synthetic tags are super valuable if you have very limited I/O that you're using to build a model. One of the first models we build with customers is an instrument drift model that's taking a single input, but then we use and add synthetic tags to create additional data around that to look for when your instrument's starting to drift, when you're having issues within that process. So synthetic tags are very valuable to add in there. They are typically statistical models that are added onto it to create that value. The other thing you can do is add in advanced rules on your runtime. So you can come in here and say, I have one rule in here already. I only want the model to run when we have a command on, and this is on as well. So created a little bit of logic in there. I've also included that in the training and the runtime. So once you've deployed this model, these rules will apply as the model continues to train. We hit next, and this is where the most amount of data science you will be required to learn and commit to memory. We have 6 different model types in here. We have clustering, which is a simple anomaly detection. You have classification. You've found a problem or a pattern. You want to match that going forward and only match that pattern. You have regression. You're trying to predict a certain set point. Optimization. This is our advanced process control, multi-objective process control piece. You have the digital twin and then the forecasting. So when you start off and you want to build a model, this is where you will kind of come in here, pick from whatever one you're trying to accomplish and select. I'm not going to build an optimization model. We're just going to stick with a simple clustering model here, but I want to walk through the steps of how we've tried to simplify this to allow SMEs to be able to rapidly build and iterate on these models. Very simple process. You can pick as many objectives as you want from this. So in this case, we want to minimize our power consumption while we maximize torque. So those are the two variables that we want to deal with, trying to find the optimal set points to run by. You can pick more if you want. If there's other objectives you're trying to accomplish, think of different processes you have throughout your facilities, what you're trying to optimize to, and also minimize as requirements. Then you have an independent variable. Well, it's something I can't control, or I could control, excuse me, but I'm not going to in this scenario. So we're going to go with speed. That's going to be the piece here. And then what is the part that we want to control? So an actual closed loop control. Sorba can run in both open loop and closed loop controls. So if you want just a recommendation to come to your operator's dashboard saying, we recommend going to 45 Hertz right now, that is an option. Or once you become confident with the model, you then can write that back down into your PLC, into a set point, or wherever you want that to go. In this case, we're going to pick, I'm just picking a random thing here to control to, we'll just say output frequency. Then you can add additional variables that you want in here. Now, when you get down to the bottom, you can add in anomaly detection as well as doing a digital twin at the same time. If you notice in the algorithm name, it says auto. We have a patent on our auto ML. What this does is it takes your data set and the parameters you're trying to solve for, and it runs it through a whole host of, whole host of different algorithms we have built into the software. So if you have data science people on your staff, if you know a certain algorithm you want to use, you can come in here and you can pick that, adjust the settings, play with the parameters, figure out all those things. I am not a data scientist. I don't know what any of those parameters really do to impact a model, and I'm going to leave everything in auto. This will then run that entire data set you have through all those algorithms and pick the best combination of algorithms to solve that particular problem with that data. So we'll come back up here. We're going to go to a clustering model. We're going to leave it in auto. Again, same scenario. If you have your own algorithms in here, you can come and pick those. We're going to leave this in auto. We're going to click next. We have a data set here, and we're going to click and create analysis. That is building a model within the Sorba system. You have that ability to rapidly generate stuff. Of course, I'm getting there, so we'll go into one of our pre-built models. I was joking with Bob yesterday. I haven't had many errors, but here we go. In that anomaly detection, we have this model built out already. These are the standard dashboards that pop up once you've built the model. So every time you build it, this is a standard dashboard that pops up for anomaly detection. Optimization has its own dashboard. There's a whole host of different dashboards that come up. You can also create custom dashboards and save those as well. But in this case, you have all the different data. We'll expand this out for a bigger screen. And you can look at the anomaly detection that was identified inside this data set. So this is about 3 months worth of data. You can zoom in on the data and, look at the patterns and different behaviors that built up to this anomaly occurring. Once you've identified this, maybe this was a belt that broke. Maybe this was just, a binding that occurred on a bottling line. Whatever it might be, you now can reference it back to your CMMS system. You can look at what your operators are doing on the ground, and then you can start tagging this information. So sit here and say, this was a sensor failure, provide some context. Now you've annotated that information. You can go build a classification model and now start putting this into production. You can do this with a whole, host of the information coming across, explore into it, go back and build another model, take out some of this other information, seeing if some of these tags are impacting things more than others. And we provide a lot of that data here in that analysis. So you can look at the drift of the data you had, where you had substantial drift around your information that came in. You can look at your data quality and see, if you had any real substantial data quality issues as it was coming across. Also, you can look at the tag ranking and see which one of these tags really had the biggest impact versus things that you could potentially take out because it doesn't really impact that anomaly detection model. Plus a whole host of ways to look at your data so that you can try to determine what's really impacting your processes and trying to optimize as best as you can. So with that, we've built the model, we've put it into production, or excuse me, we haven't put it in production, but we've built a model and we've looked at the different things we want to solve there. The next piece of this is now putting this model out into production. With that, you come back over into the IoT Unified and you come into your model instances. You can put as many models into deployment on certain assets as you want. This is entirely up to you of what you're trying to solve. In this case, on this refrigeration application we have here, we have an anomaly detection model, we have an advanced process control model, and then we have a secondary model running, looking at certain predictions. When you come into these models, this is where a lot of the auto retraining and the kind of programmatic and deployment piece comes into play. So everything, again, is menu driven. We try to put an easy button on everything we possibly can. This scope of work is being deployed at the edge, but you can deploy in the cloud or in a hybrid manner. In this case, we're keeping it at the edge. You come in here, you pick your project. Every single project has a unique identifier. As it creates revisions, it will have a unique identifier in each one of those revisions, so you have revision control. Come in here, you can change the parameters. If you want to have anomaly detection only kick in at 85%, not 80, which is the standard, you can make those adjustments. And then the most important part is really around the auto learning. So, as I mentioned earlier on, one of the biggest pieces, the biggest time commitments you have in building models is really around the auto learning as the data collection. So to be able to put a model out there in production quickly, have it get better over time without having to collect immense amounts of data, you add the auto learning. You can set the parameters here to retrain every 2 weeks, just on a very periodic basis, or you can do it when you have a substantial amount of drift. Either way, the model will then create a new version of the model. You can keep as many versions of that model as you want. You can also update, delete, or disable the model and a new one is created, depending on how much storage you have, depending on how rapidly the models are updating, the dynamic nature of your process, etc. As well as you can have a rollback option. So new models created, the new model scores worse than the previous model. Do I want to roll it back to my previous model that was already in production until I can do some root cause analysis on maybe what's going on? Maybe there's been a substantial change in the operation of that gear. Lots of different options there, but this allows you to get started with very little data, put it in production, and let it start retraining on its own and get to the best model that possibly can be. Additionally, if it finds a better, more effective algorithm to run off of, it will do that as part of this retraining. Finally, you do some IO mapping. In this case, too, we try to create easy buttons along the way. So if you need to generate tags, you have auto tag generation and also auto tag matching for matching up your different tags as you go across. So in this case, you have your input tag. So this is coming off your equipment or from your historian. And then you have your output tags. All these tags are now exposed, so you can map them in your historian, put them on your SCADA system or DCS, really wherever you want to move this data. But these tags now become available to look at in dashboards that we have created within our software. So this allows you to put these out into real life and move data and continue to see that impact that this model is making. The last piece I want to touch on is in classes. So you built the most amazing refrigeration model. that you could possibly imagine. Now you want to move this model across your entire enterprise. You have 50 refrigeration units and you want to push these, into different spots. You now can take this and create a class. Now you've bundled up all those different artifacts that are inside that asset and you've moved them into a bundle. That bundle now can be ported to wherever you want. You can then all you have to do is remap it. Once that model's deployed, it'll start retraining on that data coming from that specific asset and learn what the appropriate behavior and response needs to be for that specific asset. So it really creates, if you have 1,000 VFDs, you create a VFD anomaly detection model looking for faults on, high voltage spikes. You build it once, you like it. Now you can put it out to scale and have that across your entire enterprise. So with 15 minutes left, I do want to turn it back over to Bob. If there's any questions we want to go into, talk about a few other things. We just barely scratched the surface, but I wanted to kind of touch on some of the high points from an operational perspective of the ease of use, the ability to iterate, and really drive value quickly in your facilities. First model is not necessarily always going to be the best model. It may not be solving the problem. As we've all been in the engineering space for a long time, there's some tinkering that we all do, trying to solve the problems in our unique manufacturing environments, because we all know one size doesn't fit it all. And having that ability to create real custom models rapidly is a huge shift in the way that this AI and ML is being deployed into the marketplace. So, Bob, over to you.
Yeah, you could stop sharing. That way I can kind of take it back. But what we're going to do now is a couple things. One is, cover real quick. Where do you go next? Where can you go next? What can you do next, right? And I will say, get in touch with me, get in touch with Brian. And it is really this, where do you start? It's a lot of, that's what we're here for, is we have these discovery meetings, look at your, infrastructure you have, let's say of Tatsoft and Canary, and here's all your data sources. Here's the areas in your manufacturing that you want to improve. I mean, that's really what it comes down to. I want to improve. I want to be better. I want to reduce costs. I want to do all these other things. And that's really the next step that we have in there, right? Is, it's a readiness survey, digital transformation readiness survey, AI ML readiness, and figure out what you're going to do and get started. Part of it is one of the things that we really like about Sorba.ai is this can scale to whatever you want to. And some of the best things to do is just get started. Just start using these tools and technologies that are out there to solve individual issues without it making it this big, complicated, big data AI project that costs millions and millions of dollars, right? So we'll kind of conclude with that. We do have some questions, so I'm going to bring Isabella back in. Me and Brian's emails are at the bottom, so you'll know how to reach out to us afterwards. And again, as I said earlier, we're going to answer as many questions as we have time for. Anything that is left over, we'll definitely reach out to you directly and answer those questions. And some of those questions may be ones that are done on a one-to-one basis anyway. So with that, Isabella, if you want to start with some of the questions.
Absolutely.
And if you have additional questions, please add them to the Q&A chat and we'll get those answered.
We have quite a few. Brian's already typing some answers as well. But I will kind of repeat the question. The first one was if the solution can be deployed 100% on-prem below the firewall. And as you've answered,
yes,
Brian, I think it's worth saying it for everyone as well.
Yes. So as I mentioned, the two co-founders of this company are controls engineers. The first thing they always heard was, no way my data is touching the cloud. So our solution, every feature, functionality that you saw within Sorba, even when we release our LLM, everything can be deployed on-prem first and foremost. We will not release our product with a feature that cannot be done that way. That being said, some people want to connect to things. They want to connect to ChatGPT or Claude or do this. Those are all things that we have that functionality. But our primary, I would say 80+% of our customers deploy 100% on-prem in an air-gapped solution. And that's their preferred method. And our software runs 100%. All of this functionality you saw and more runs run that manner.
Nice. Perfect. And I think I can put it here. No, the second question was, if we want to use the cloud, is there a preferred cloud provider?
We do not have a preferred cloud provider. We have deployed on AWS, Azure, and Oracle. But how our software is built, it can deploy on any cloud to the best of our knowledge. Again, we'll do some testing. I don't want to say 100% absolute, but because we haven't tested them all, but we have built the software to be cloud agnostic. So we are on the Azure marketplace, but it really kind of depends on what your preference is.
Sure. And we're talking about hardware, is there anything specific that the solution needs for it to work?
No. So we primarily deploy on CPU, as I mentioned. If you add a GPU, software will just run faster. We typically run minimum requirements we need is a 16 gig, 8 core, about 250 gig of memory or storage, excuse me. That is our kind of minimum requirements that we request. We have a couple hardware provider announcements we'll be making here in the near future who have already kind of tested our software and the failovers capabilities. So we'll be announcing that here soon. But yeah, there again, we are hardware agnostic, and we can spin up on a VM, Ubuntu, Red Hat, and Docker. Those are kind of the 4 flavors we have on our download, our portal.
Perfect. And I also got a question of here. What systems can you guys connect to?
So I can provide, the all-inclusive that we currently have drivers for, for like a direct connection, both on the IoT unified piece, but, connecting into Canary, OPC UA, Pi, those kind of database sources we have built out, Ignition's Historian. We also have the connections down into Rockwell Siemens, Modbus, TCP, all those kind of standard automation drivers, as well as some kind of weird ones that we've built because we're doing work on a train and we need to connect into the control unit on a train so we could look for failures in that equipment. So there's some obscure ones in there that you probably don't run across on a regular basis, but we have, I think, over 60 different native connectors built in, and we're constantly adding to that as well.
Perfect. The next 2 ones I actually know, which is there a download available and is there a learning center? And you send me those links. I will put them on chat, but if you want to intro it.
Yes. So we have the portal, the Sorba portal, so you can download a 2-hour runtime. When the runtime, the 2 hours runs out, you just have to restart it. You can go back in and continue playing. You can download it into whatever environment you like there, as well as the Sorba University, where you can go in and get certified on the product and do different lessons. There's a lot of lessons in there. We're constantly revamping that as we release new product. We are releasing version 10.6 here, I believe, the end of next week. So that is a new release where there'll be a lot of new features embedded in that as well. So those are the 2 links that you can download information from.
Perfect. And Rafa here asked, what is the database in Sorba which takes in all the data, and what schema created there, including contextualization?
I will have to defer. That's a great question to take up with one of my technical team. I know that we have 3 different databases in our software. We have our own internal historian. We have, I'm going off memory, so please don't quote me on this. I believe it's Influx we're using on the real-time database. And then there's a third database that we're leveraging as well. So it just depends on the workload that it's managing inside of the software. Plus, there's a lot of other features to dive into. If you have your own databases that are set up, you want to map those. There's a lot of different things you can do with the software on the back end. I went through the easy version. You can do a whole host of things and connecting with APIs in different parts of it. So depending on what your current infrastructure is, it really comes down to how you want to deploy it.
Perfect. Another question here, which is different data comes at different frequency. When you add them all in one group, how is the missing data filled for slower data signals?
So, and this is again probably one of those questions that can be better answered by one of my data science team members. But what you can do as part of the process of bringing in data is to get full complete data sets across, which is an important part when building models. So if you have 1 second data coming here, but you have 1 minute data coming on another column, you can fill in those other datas with, fill with previous value or discard nulls. There's a lot of different ways you can line up and cleanse that data as it comes in. So it really just depends on, which one you're trying to set as kind of the core piece of that data you're trying to leverage, and then using fill in with previous value. We've found that like a lot of people set up a historian to only record on change, for example. And I've had a few calls, hey, your software doesn't work, it's rejecting all this data. Well, they forgot to put a filter in there to say, hey, fill with previous value, so you have full data sets and you're not rejecting all those nulls. So there's a lot of different tools inside the software depending on what you need to do to align that data to get it all stacked and available for use.
Perfect.
Yeah, the good part is it's all tools, right? It's not a lot of code. It's just go through the tools, use this, pick and choose, do what you need it to do to quickly get your data cleansed and ingested and cleansed. It's one of the most powerful features of the software.
Perfect. This one's also quite a technical. See if you can answer. How fast can you inject, I think it was what he meant, images, and how many frames per second? I think that's what he meant.
That's up to the camera. We can ingest as much as the camera can feed in on the, I'm assuming this is on the vision side. So we can ingest as much as the camera's bringing in. On just to give you on the time series side, we do a lot of stuff in steel. So we pull in millisecond data, to make those reactions there. So really that it just comes down to, again, our software can pull it in and process it at whatever rate we need to. It just comes down to, if you're doing millisecond data, you're doing high frame rates, you might want to throw the GPU out there so that you have enough compute to do that work, rather than trying to run it on like a, minimum requirements for a CPU. There's another question that I think Ravi threw in there. I just want to answer because it's right. My eyesight, how much accuracy is lost? None. Deploying at the edge. So we are deployed on-prem all the time. So that is where our primary solution is built around. So no accuracy loss. And it's our normal standard install is being on edge or on-prem. Again, it comes down to really more what hardware you put in, how you want to collect the data, how accurate or how granular your data is coming into the system. So if you want to pull in millisecond data, we'll take millisecond data. We can build a model off of that millisecond data, and we'll cleanse it and do all the necessary things to get it prepped for data science. So, and one of the things from an edge deployment, if you want to run a specific edge processor, and that has millisecond data, but then you only want 1 second data going back up to a different process to spare your network or your historian or whatever it might be, you can also configure it that way as well to do work on an edge node at a high level of granularity and then push back the appropriate information to whatever other system you want from more of a record keeping perspective. So those are all things that can be built and deployed within the system.
Awesome.
We got time for one more, Isabella. Yeah. And if you have additional questions, I put back the screen with me and Brian's email. Or if you do want a more technical dive, deeper dive, learn a little bit more, this is really much an overview of what we do. Email either one of us, and we will be doing a follow-up with some more information for the links, the chat, where the documentation is, where the download is, how do you get a hold of us. So one more question, and then we'll conclude.
Yeah, this is the last one as well. I think you can see it, right? But it's in a total cost of plant replacement, what is the ratio of such system, including the physical and non-physical assets to operate it, if it's considered during the design stage of the manufacturing plant? Quite a mindful.
Yeah, that's wow. I don't know how to answer that, to be honest with you. I think when I look at what our product does is it's an augmentation to, you lay it on top. So you're going to build out your normal PLC infrastructure, your normal, the PLC is still driving that as your primary process. What we are is coming in and creating that real time closed loop value over the top. And so if we're to look at just like instrumentation calibration piece, yes, it's something that's immensely valuable to build in. I think it's part of a greenfield project, or you're doing major retrofits. In terms of the total implementation cost, that's a piece we'd have to kind of touch on, and looking at the details of your infrastructure and how you want to lay that out. But more than happy to kind of dive real deep into that conversation if you have some concrete examples, or even throw it on a cocktail napkin and kind of figure it out from there.
Yeah, one of the big things I'll say in that, and this is very high level in there, right, is you start looking at designing of a plant, et cetera. There's a couple of things is make it digitally ready, right? Make sure that the equipment you have it talks reliably, it talks with the resolution that you want it to, right? It's a good example. You use a camera, right? Make sure the camera, and your network structure and everything you have in there can do that. Because the key thing is if you can get the data and you can add the infrastructure in place, you can take advantage of these tools, and it's a good time to do that. I'm sure all of us have equipment that's in our plant. As you said, some of it may be manual data. There's no way around that, right? It could be, I need you to observe something and record it, right? Then it's manual data. Well, you need to make sure that, that's a good understanding. So it's good in there, as you said, from a design perspective, to make the data as digital as possible.
Correct. And like Bob said, I will share the Q&A, the answers of all the questions, as well as the presentation later in the week. Any last thoughts, Bob?
Okay. No, everyone, thanks for 2 minutes over, which is not bad for anytime we're doing this. For those who hang on, thanks for participating, and we'll likely be in touch in the near future. Brian?
Yeah, thank you very much. Love this. Love having conversations around this. Very passionate about what these type of tools can do to help manufacturers. So thank you for the invite, and I look forward to chatting with everybody who's on this call today.
Thank you, everyone. Thank you for joining. We'll talk to you guys soon, and look forward to my follow-up with all those links and everything we discussed today.
Yep.